Well, good morning, or wherever it happens to be, wherever you are. My name is Steve Samuel from Design Visionaries, and today I'd like to share with you some geometry techniques that were inspired by one of my favorite architects, Antonio Gaudi. Now, Gaudi was a architect who was born in 1852, died in 1926. I guess he was run over by a bus, so that's kind of tragic. But the thing that I love about Gaudi's work is it is so incredibly innovative and modern, and the shapes are amazing. So, arguably his most famous work was the Sagrada Familia in Barcelona, Spain. And I've been there. I've been to Spain and really appreciated his work. And he did this other building, Casa Mila. He did a bunch of them, but these are the ones that really, I don't know, are incredibly inspiring. And some of the geometry that you can see on these buildings is something that looks like, that at the time that he designed them, he must have had this amazing CAD system, but of course he didn't. And the curves and I'm going to call it the humaniform nature of his design is something that's always really blown me away. Love it to death. So here's another building, Casa Battillo. Like I said, amazing structures. And so for industrial designers like myself, I take these shapes, I take these forms, I take the concept behind his design, and I try to apply it to actual products. Now, this is not my design. This is a design that obviously was inspired by Gaudi's work. It's a coffee maker and an espresso machine. This is not a real thing. But in order to create that kind of geometry using NX, there are techniques that I would love to show you that you can use to do this. So in order to proceed, I am going to show you some really cool things that I think are amazing in NX. So I'm going to delete all these entities here. Okay, and I'm going to show you some techniques. Okay, so I'm starting with a sketch. This is a very simple sketch. It's got three arcs basically, and this flat line back here. And this is like something that would be a typical housing for, let's say, a copy machine or some electronic devices that you'd have to make some cover for. So I take the sketch, I extrude the sketch. Let's go to extrude. Yep. Let's do them all. It's connected curves. And let's go 23 inches. And say OK. Then I'm going to blend off these corners. When I blend the corners, I'm going to blend them with a G2 curvature continuity curve on the basis of a 5-inch radius with a 0.65 RHO. So that way I'm guaranteed to get some really smooth transitions on those curves. So in order to show you that, I'm going to do a section analysis. And my section analysis is on these nice little show combs, these nice little faces. And I'm going to increase the scale of the combs so that you can see that the transitions between the edges of the blends and the rest of the curves are very nice and smooth. So that technique right away with the fillet tool is very powerful and great. Okay, and then I'm going to make a datum plane, and I'm going to create a datum plane that's offset from this face by -2. And the datum plane gives me the ability to do an intersection curve, and I'm going to intersect these tangent places with the datum plane. Say OK. And I'm going to take those curves now, and I'm going to combine them with a composite curve, and I'm going to use a join curves with a cubic mathematical definition, and I'm going to hide the original. So I take all of those curves and I blend them into one. The reason why I'm doing that is because I want to do a sweep along that guide. So I go to Sketch and I do On Path, and I grab the end of this doodad here and move it all the way back and say OK. And on that path, I'm going to put an ellipse, and the ellipse looks like that. And when you do an ellipse, you do have to constrain it with a horizontal constraint. As you can see, there's a rotational degree of freedom here, and you want to get rid of that. And once you do that, then you can feel free to put dimensions on it. If you start putting the dimensions on this sketch, on the ellipse, before you constrain it in that way, it'll start rotating and going, for lack of a better term, cockeyed. It's a technical term, cockeyed. And I'm going to put 2 dimensions on here. Those dimensions I can use to control the shape of the ellipse, obviously, and I kind of like it the way it is. So I'm going to do that. So now what I want to do is I want to sweep this ellipse along that curve, but I want it to be bigger and smaller and bigger and smaller. And what I'm going to do here, and it'll be very apparent why I'm doing this, is I'm going to distribute 9 points along that curve. So I'm going to just select that curve, the composite curve, and its curve points. I'll put a point set on it, 0 to 9 or 0 to 100, 9 points. Say OK. And now once I've done that, I can do a surface swept. And the swept function is an incredibly powerful surface. And not a lot of people know all the ins and outs and all the different things that you could do with this. And so one of my favorite things to do is a sweep along the guide, or I'm sorry, a sweep with a perimeter law, and the law type is cubic along spine. So what that means is I could select the section, and then I can select the drive curve. And then what NX is prompting me for is the points along this spline curve, and on each point I can put a different a different perimeter. Now, let me back up a step. I'm going to get out of that because I would like to make 2 parameters, A and B. A will be a large number, B will be a small number. So I'm going to say Control E, as I do ever so often, and I'm going to hit New Expression, and I'm going to create a variable A, and that variable A is going to be 6.78 inches. And B is going to equal, hit the tab key, 4. So I've got 2 parameters, and that's what I'm going to use to control the perimeter of the section as it goes along the sweep. So I'll go back to sweep. Okay, I will select the ellipse as a section. I'll select my my joined curve as the drive curve, and then I'm going to make sure that my orientation method is fixed, my preserve shape is on, my scaling method is perimeter law, and my law type is cubic along spine. Okay? Actually, I don't really need the preserve shape on because I don't have any sharp corners on this thing. So now I'm going to make sure that I click on this little icon, existing point, and I'm going to select the first existing point. Click it again, second existing point. Again, now I'm going to go to the rendering style static wireframe so I can see the points that I'm selecting, and point, and point, and point. Zoom up a bit, point, zoom out, and this is the tedious part of our program. Point, point, and point. Okay, so now I have 9 points, at least I hope I do. There they are. They're all in this nice little list. And the list is great because now I can click on any of those points and I can assign the correct dimensions. So for example, I click on point number 1, and right here I type in the variable a, I put a space after it, and then I click on point 2, and this one is b space, enter. Click on point number 3, this is a space, enter. 4, b space, enter. 5, a space, enter. 6, b space, enter. 7, a space, enter. 8, b space, enter. 9, a space, enter. And there you have it. Now you have this piece of geometry. This geometry I'm going to use as a cutter. But I need another corresponding geometry that will be small, big, small, big, small, big. So I'm going to put another datum plane here. And this datum plane is going to be offset by minus 5. It'll be apparent y in just a moment. Minus 5. And then I'm going to do it again. I'm going to do an intersect curve, intersect these tangent faces with the datum plane. Say OK. I'm going to go to the curve function and do a composite. And these curves will be combined into one nice cubic spline. I'll hide the original. Say OK. And then I'll go back to the sketcher. And I'll go to the on path. I'll select the path. I'll move the sketch to the very beginning of the path, and I'll put in yet another ellipse. There's that. Say OK. Finish. I'll go back to surface. Surface. Swept. Okay, isn't this fun? My swept is going to be very similar to the last one, except this time it's going to be small, big, small, big, small, big. Before I do that, I've got to go to the curve function and go to the point set function and select spline. I'm going to put 9 points on it again and say OK. And now I go to surface swept. And with surface swept, I select the the ellipse as the section. I select the combined curve as the drive curve, and I need to now specify those points again. Before I do that, I'm going to go to rendering style, static wireframe. It's the easiest way to go with this. I'm going to click on existing point, and I'm going to select the first point. Did that work? There you go. First point, click the button. Second point, click the button. Zoom out a little bit. Third point, button. Fourth point, button. Fifth point. This is the tedious part. Button. 6. Button 7. Button 8. And button 9. Button 9. Okay. So, cool. If I did that correctly, I will have 9 points. There they are in full display. Only this time, I'm going to click on point number 1 and give it the value of B. Enter. And the next point is the value of A. A space. Next one, B space. Next one, A space. Next one, B space, next one, A space, next one, B space, next one, A space, and finally B space. And apply. All right, so now we have two cutters, and they should be alternating. Looks pretty cool, in my view. Gaudi would be amazed. He would be rolling, well, poor guy. He would be, I wish I could meet him. Pattern feature. No, I don't want a pattern feature. I think I'd like to go home and pattern geometry. Pattern geometry. So I'm going to pattern this one in a linear fashion with a pitch distance of 6 and a count of 4. Good. Apply. And then I'm going to pattern the second cutter with a pitch distance of 6 and a count of 3. Like that. So they alternate inside of each other just like that. And there is almost the piece of geometry that I want. I'm going to subtract all of these cutters, if you will, from the case, but before I do that, I'm going to take this little face right here and I'm going to offset it just a little bit, minus 0.25, and say OK. I'm going to go to the subtract tool, subtract, there's the target, and a bunch of tools, and say OK. And oops, when I did my subtract, there was the keep tool on, so I'll get rid of that, say OK. Then I'm going to do that offset. I'm going to put the offset back, 0.25. I did that because I was thinking that the cutters would be face on face, and that's not a good thing. I'm going to shell the whole thing out, shell this face, and this back face, and this bottom face, and say OK. And oh, before I shelled, I think I wanted to smooth out these edges with a blend. So I'm going to turn the model back in time by saying make current feature. I'm going to go to the edge blend tool and I'm going to do another G2 curvature continuity edge blend with 0.65 RHO, and this one is going to be, how's 0.25 look? I think it should be a little bit more like that. So that's a 0.5 based on a 0.5 radius. There we go. That looks good. This one, this edge, this edge, this edge, this edge, that edge, that edge, 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 edge. And say OK. And go back to the shell. And there it is. There's the finished housing. With a little Control W, I will clean up all that. I'll go into my studio representation. And there you have it, this beautiful housing inspired by Antonio Gaudi. I highly, highly recommend that you travel to Barcelona if you can and take a look at all these different wonderful buildings that he designed through his life and times. And evidently the most famous one is scheduled to be finished in 2026. So that's how long this thing's been, you know, poor Gaudi, he died in 1926, and and now hopefully the building that he envisioned with his an amazing imagination will be done in 2026. Again, my name is Steve Samuel. Thank you so much for many of you liking and subscribing to this channel. I feel very supported by you. It's a great user community. I'm getting lots of emails, and it's wonderful to be involved in this design community. Design Visionaries, please check out the channel at www.design. No, well, it's YouTube at Design Visionaries, and I really appreciate it. Thanks again, and I hope you use these fantastic techniques to your great advantage.